Hello, it's Mr. Muller for lesson 3-6, solving compound inequalities. Alright, so today's going to be a little different than all the other days, probably the hardest lesson of chapter 3, kind of putting together everything we've done, plus kind of got to think about it, which way the signs are going, especially today. So compound inequality is kind of like a compound word. You're putting two inequalities together, so sometimes can be confusing with the way the signs are going, like I said earlier, but it's literally just doing kind of two problems at once. So like if you'll see something like this, it says all numbers are bigger than 2 and less than 6. So we've had problems like this where we've written, all numbers bigger than 2, all numbers less than 6, but now we're kind of just putting them together into one sign. So here's that first part where all the numbers x is bigger than 2, and there's that second part where x is smaller than 6. So kind of the same thing. And then when you graph it, then we know our answers are really only between 2 and 6. So if I'm telling you pick a number between 1 and 10, well, what would the graph look like? I wouldn't, 0 wouldn't be highlighted on the graph, or 11 wouldn't be highlighted on the graph, because I'm telling you to pick a number between 1 and 10. Kind of the same thing here. If I tell you to pick a number between 2 and 6, your options are really 3, 4, 5. I didn't say 2 could be included or 6 could be included. So again, with those open circles there, we have that. So kind of what we did before, but a little step harder. And then, probably looking at Venn diagrams, something like this. So if A is numbers less than 10 and B is numbers greater than 0, well, there's a lot of numbers that are greater than 0, and there's a lot of numbers that are less than 10. But there's only a few numbers that are less than 10 and bigger than 0. So kind of using a Venn diagram to show the numbers that we could use that are true for both. So example here, like with pH balance of shampoo or like fish tanks or pools, it has to be a certain level for the pool to be safe. If it's if it has too many chemicals, well then it's not safe, because then if you accidentally drink the water, something bad can happen. Or if it has not enough chemicals, well then it's not going to be clean enough for you to go in there, and then you can get sick because of all the bacteria. So for this one, it says the pH balance has to be between 6 and 6.5. So there it is. It could be at 6, that's fine. It could be at 6.5, that's fine. Or it could be anywhere in between. If it was at 5.9, not safe for us. If it was at 6.6, it's not going to be safe for us. So kind of some real life examples there. Kind of the same thing here. Numbers less than 10, numbers bigger than 0. Yep, there's a lot of things that are bigger than 0. Yep, there's a lot of things that are less than 10. But to put two of them together, we only get a select few answers there. And the way we would figure it out is pretty much setting up two separate problems. So I would really look at it like this. So there's my whole problem. -9 is less than x minus 10 less than -5. I'm really just going to look at it as two different problems. So -9 is less than x minus 10. Well, then I'm going to add 10 to both sides. That's going to cancel out. -9 plus 10, I get +1 is less than x. And then I'm going to do the same thing for this side. Think of it as another set of problems. I'm going to add 10 again to both sides. And so I get x is less than 5. So there's my two answers right there. X is going to be bigger than 1. And x is going to be less than 5, and then this is what it would look like. Oops, have that go away now. X is bigger than 1, so a number bigger than 1, and x is less than 5, so a number less than 5. So really only the numbers 2, 3, and 4 would be solutions for this inequality. Kind of the same thing here. Again, I would get a sheet of paper, something to kind of block off that edge, and kind of just separate the problems into two separate problems. So -1 from both sides, -1, I get -6 is less than x. So I know x is a number bigger than -6. And then kind of the same thing. Let's look at it from the other side of the problem. I'm still going to subtract 1 from both sides, subtract 1, and I get x is less than 1. So now I'm looking at a number that is bigger than -6, but a number that is less than -1. Sometimes we'll have 2 steps, we'll need to multiply and divide, but again, we've done that before in earlier sections, so that's really nothing new. And then we'll have some where we'll have to read the graph, so kind of like this. M is bigger than -2 but less than 5. And then if you ever see problems that are like this, so kind of the same thing here. So M has to be bigger than -9 but less than -2. So there's going to be a bunch of numbers like that. Bigger than -9 but less than -2. And we call this an AND problem, because our numbers are our answers are very nice and neat. They're in the middle, somewhere between -9 and -2. This one gets a little more confusing, where it's going to be an OR kind of problem, where the answer could be less than -3, which are a billion numbers, or the number could be bigger than, should be a 2 over here, bigger than 2, which again, could be a million numbers. So really, the only answers that don't work are -2, -1, 0, 1. So AND has a select number of problems that do work, OR has a select number of numbers that don't work. So pretty much if you can pick any number here besides -2, -1, 0, 1, and it's going to make this inequality true. But here you can only pick -8, -7, -6, -5, -4, -3. That'll make it true.